Hi everyone, and welcome to our video on solving logarithmic equations. So there's two kind of setups that we use based on how the equation works, and it's in these bullets right here. Okay, but let's jump into it and solve these. So to solve for x in these problems, what we need to do is use the definition. I call it the smile rule a lot. Smile rule. Because I think like this right here, this base of 3 connects to the 4 and it makes the smiley shape. And we could write this as 3 to the 4 is this leftover argument, the 4x minus 7. And so 3 to the 4 is something that we can do. That would be 81. And then now all I'm looking to do is solve for x. This is now linear, so that means I can add the 7 over. If I add the 7 over, I would have 88 equals 4x. And then now I could divide by 4 to get 22 is x. And then that's it. Okay, so it really just depends on remembering how to rewrite it in exponential form. Okay, so moving on to number 2. Here we've got this log. However, it's not completely by itself like it was for number 1. So when you have these style problems, before I apply the smile rule, I need to make sure that this is isolated. So the log needs to be by itself, which is not that big of a deal. All I have to do is divide by 4 to make that happen. So I'd have 2 is equal to log of 5x. And this is log base 10. So we can always put that into help. And then that way we can see it maybe better when we apply the smile rule. So this 10 will get squared. So 10 squared equals this argument of 5x. And then 10 squared is something we can do. That's 100. And then now all I have to do is divide by 5, and we would get x is 20. And then that's it. It's done. Okay, so that's how we can break these down. So it's a quick rewrite, and then it turns into usually a pretty easy equation. Okay, number 3, let's go ahead and rewrite this. Remember that this is log base e of 9x equaling 4. And let me make sure that that looks like an e. Okay, so log base e of 9x equals 4. And then I'm going to apply my smile rule just like I did the previous two problems. E to the 4 would equal that 9x. All right, so smile rule applied. Now here's what's good about e is that we can't do it. Now if we needed a decimal, we could plug it into a calculator, but often they just leave it as is. So this e to the 4, we're just going to leave as is. And so if I want x by itself, well, I would just divide by 9. So my final answer will be e to the 4 divided by 9 will equal that x. Okay, so we get some unusual looking answers sometimes depending on what we have. If they wanted a decimal, we could plug this into our calculator to change it. Okay, so also notice on this one it was isolated at the start, kind of like number 1, so I didn't have to do too much to solve for it. All right, number 4 and number 5 are a little different styled, where I have a log equal to a log. Well, these are both base 10. You can put that base in there if you want to, so there they are. But the main thing that's important about it is if I have one log on one side equal to another log on the other, and they are the same base, so they're both base 10, then that means all I have to do is set the two arguments equal to each other. Okay, so it's saying log of this in the purple equals log of this in the purple. So what's in the purple boxes should be the same. So 2x plus 3 then equals 9x. So I think these ones are even a little nicer than the 3 above, because now it's still just linear. I can subtract the 2x over. So I have 3 equals 7x. And then if I divide both sides by 7, I would have 3/7 is x for our final answer. All right, so that's how we can break down this style problem. All right, so now one more here. This one has multiple logs on one side. Well, there is a rule that would help us. It's right here. Okay, so it's right here. Actually, let's highlight the whole thing. Where it's telling us, because I have this plus sign right there on my left side, so I'm just highlighting it, it's saying I should multiply my first argument of 4. Let me do that in pink, actually. That 4 and the 3x. And then that should equal the argument on the right. Okay, so if we use this rule, so that's what it's telling us. So this argument multiplies this argument. That's what's happening right there. And it equals that argument on the right side. All right, so this means that this 4 times this 3x is equal to the 6x plus 2. Okay, so this is called the condensing rules for logs. So there's other rules in logs that are useful for us, but I think this is all we really need for these style problems. Is just one extra little rule there. And so now I can solve it. 4 times 3x is 12x. And then I need to solve for x, so I would subtract the 6x on both sides to get 6x is 2. And then if we divide by 6, I'm going to put my answer over there since it's running low on the screen. 2 over 6 would be 1/3. Okay, so that would be our final answer for this problem. Okay, so there's the main way to solve these logarithmic equations, though. So it's mostly using the definition on them to get it. But if you have a log on one side equal to a log on the other, or if you have a combination of logs equal to another, we can also quickly change it into something that's a lot nicer. Okay, so that's it. So if you do have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.